That's a nice introduction. Just one correction. We are in the middle of experimenting with open source models. I'll share my learnings. So definitely have not deployed them at scale. It's a challenge, as you saw in the previous talk as well. But I'll talk about those challenges and share our experiences, and happy to connect offline as well. Great. So let's go. So there are many use cases which are emerging, right? You already saw some of them in Jairaj's talk, and similarly at Flipkart we have text use cases where we are trying to build basically a shopping assistant, like how you go to a store and interact with an assistant. We are productivity tools, image generations, which you saw in the previous talk as well. Video, creating, sometimes India is our audience. Like they engage with images, they engage with videos. So how can we share videos of products and create them, generate them, and so on. And similarly, audio inputs, which we are working with. We have voice search and voice bots and stuff like that. Plus, there are other. We also, not to mention, we are also have our group companies like ClearTrip, Flipkart Health, and there are many use cases around there as well, right? So let's go forward. I think what we are seeing over I think this last whatever 6 months, 1 year, right? I think things are just exploding. You know that, and we are trying to really hard to be on top of these things, right? Every day this image is changing of the what kind of commercial offerings are coming in the generative AI space, what kind of open source offerings are coming. There are many more. This is just a representation. So there are many, how to choose amongst these, right? Some things are readily available, like we can just go to market quickly. Sometimes accuracy is a challenge, latency is a challenge, hallucination is a problem. You saw that. Security compliances, governance issues, total cost of ownership, right? These things are not cheap, right? So yeah, so we'll see how we can kind of navigate this, right? There are some use cases. I think the good thing is that we can share. We have few use cases where we have already gone live. We have launched GenAI. We are kind of experimenting with many more use cases. The first one is basically a conversational assistant. You can go to Flipkart and chat about any product. You can ask questions about show me good, whatever, low light photography phones and those kind of things. And it basically interact with it. It's very early. Probably I won't even call it beta, like it's kind of alpha stage, and but we wanted to launch quickly so that we can get the data. The kind of queries that we see, right, on these versus what queries we see on search are quite different, right? So we want to collect that data as much as possible. The second one is basically the summarization use case. Given a product, you can see like a review summary, take all the reviews, what are the positives, what are the negatives, and kind of summarize that for the user, right? Again, this has been done. In fact, this has been done using an in-house model, right, where we found that there are various reasons why. Because one quick thing is ChatGPT has limited context, right? I cannot pass all my reviews and say, hey, summarize it for me, right? How do we solve that? We can solve that through various layers and build internal models for that, right? So that at least every aspect is covered in the summary. Similarly, generating, like a lot of times our product quality, the description that we see of the product is not up to the mark. So we want to be able to, given what we know about the product, the text given about the product in the catalog, can we generate rich product descriptions, right? Which talk about various aspects about the product. Visual search, right? Basically, can we look at different prompts, for example, black, sports, and given the same product, give the user a choice of multiple prompts, fashion prompts, for example, here, and retrieve visually similar products, right? So let's just dive into the tech right now. I think we saw enough of kind of solutioning, right, on looking at stable diffusion models and all in the previous talk, right? Given that we already got a taste of that, to complement that, I'll focus more on the language uses cases here and try to deep dive more into that. So overall, we have our application layer where generally people will write prompts and stuff like that. We have a retrieval augmented generation, right, where basically the idea is given a set of documents, answer any questions about it. But before you can answer any questions about these documents, you need to, again, you can't pass all the documents to LLM, right? Because of limited context, you need to be smart about what you want to pass. So you have semantic embedding models, vector databases, which retrieve relevant documents, and then you basically pass it to LLMs. Now, LLMs could be a commercial model, it could be a fine-tuned model, open source model, or LLM created from scratch for a particular domain, which you see for different domains coming out, right? Like medicine, medical, and all of that. Similarly, data could be open domain data, which people have already trained models on, internal data, like our catalog, our reviews, search queries, and all of that, synthetic data, and so on. And I think I cannot emphasize the bottom part, right, which is the MLOps layer. I think this is something that is really, really the backbone to serve these large language models, to train these large language models. You require a lot of hardware, you require a lot of GPUs, both for training and inference. Unless you have a strong layer sitting for enabling everything above, it's very difficult. So again, there too, we are experimenting with multiple things and building it internally, external cloud providers, and so on. So let's go further. So I'll walk through a case study. Let's deep dive and kind of go how we basically are going about building the end-to-end shopping assistance, right? So what is end-to-end shopping assistance? You can go to Flipkart, you can chat about any product, you can ask any questions on the search page or whatever. For example, I have an old 2-star AC, should I buy one? I'd give you an answer using world knowledge and everything. Give me some options. Okay, then what is a good AC to buy in Kanyakumari? You realize what is the temperature over there, what kind of ACs will work, and best discount, and including offers, right? I think this is very, most people want to know about what offers are going on and which offers are relevant for the products I'm interested in and so on. So we've integrated our offers, databases, and everything also along with this in this pipeline, right? Let's move forward. So this is how the overall, at a high level, right, the architecture looks like. So I'll walk through like one query, right, how it is served basically. So let's say a user is asking for 5G gaming mobiles under 50K. So that query, we have to determine what is it about. It's a discovery query. There could be other queries. For example, user wants to ask whether this particular, jacket comes in other colors or whatever, something like that, or whether this particular phone will work under, is it waterproof or not? So those are product-specific queries. There could be queries around offers and all of that and so on. But let's take up a discovery query, right? Because that's more challenging. So now what we do is we take this query and we try to extract aspects about this. Here you see aspects are, for example, 5G, the display, 5G gaming. I think there is some error with respect to the example here, but yeah, we probably had a different query earlier. But anyway, I think we extract the aspects which are basically mentioned in the query, and in this case it will be gaming, it will be 5G, it will be price, and so on. And we search into our search engine, and then we get the results. Once we get the top 3 results, now we need to we can't just show these 3 products, right? We have to explain why these products are relevant for this particular query. So we get context about each of those products. For example, that this is the relevant product specifications, the user reviews. Again, for every product, we can't give the entire user reviews. So we summarize the user reviews for that product and then give it to the LLM. And then once we have that product and its relevant context, we give it to a LLM, which basically summarizes it. And then the response will be, okay, this is the phone, this is why it's a good gaming phone, there's another phone, and so on. And then we try to continue the conversation. We ask, are you looking for something else about it, right? Are you looking for higher, because we know the user is asking about gaming phones. So using the LLM's world knowledge, we know that when people are looking for gaming phones, they also look for refresh rates, they look for battery life, they look for good camera and stuff like that, right? So we ask those follow-up questions. So we try to kind of interact with the user, and that kind of really helps us, right? Making it multi-turn and so on, right? So now let's go through this, and now basically let's think about how we will go about solving some of these, right? So this kind of architecture had multiple components, right? There is a decision assistant, which given a product, it will try to answer a question. For discovery assistant, you extract the queries, you have a product summarizer, people can ask, like, compare two products. You have a router which detects the intents and so on, right? Initially, when we went, we basically tried to use commercial models for all of these, right? We just went and tried so that we can launch quickly. Now we'll talk about how do we compare that with building in-house models, right? So so this particular problem was given a product, like product specifications, frequently asked questions or whatever, right? Given a context, you have an LLM which will give the answer. That's it, right? So this is one example. We have a product which has its specifications, and somebody is asking, is it waterproof or not? And we can send it to a commercial model, and the commercial model, given this context and given this question, will come up with an answer, right? This phone is water resistant, 2 meters, 30 minutes, and so on. It works well. Many use cases it works. Many use cases it hallucinates. Many use cases it doesn't give the right answer. So we wanted to see, do we really need a very big model, right, with billions of parameters and stuff like that to answer this, right? So we tried fine-tuning open source models, okay? We took at all the various open source models. I will talk mostly about Llama here, but we have tried a lot. And we tried to basically fine-tune on our data sets. So what is supervised fine-tuning and what is parameter efficient fine-tuning? So given a task, so basically we need some label data. That is, given a query, like this previous, given a query, given the context, what the answer should be. We want this label data. Once you have this label data, and I'll talk about how do you generate this label data, that's also very interesting. But once you have this label data, then you can take an open source model, and then you can do supervised fine-tuning, or you can do PEFT. What supervised fine-tuning does is basically take your LLM, let's say your Llama 7 billion or whatever, and it will update all the layers. It's more expensive, it takes more time and all of that. PEFT will update only the few layers, right? So it's faster. And we tried both. And there are more optimizations coming up, right? How do we evaluate this, right? You saw that evaluating generative models is hard. And so what we have tried is, of course, and especially if you ask humans, you have to really train them, you have to really explain whether it's grammatical or not and so on, right? So one thing that we are trying to do at scale is basically use a GPT-4, which is a very large model, as an evaluator, right? So we gave it the output of various in-house models, we gave it the output of GPT 3.5 Turbo and see which one is better. And because we are anyway comparing with a larger model, it'll give us some sense. Of course, you also do your own manual ops evaluation and all of that along with it. And how do we, so there are multiple dimensions which are valid for different use cases. Sorry. So one dimension is basically whether it is relevant, whether the answer was relevant. Is it helpful to the user? Does it contain all the information which is present in the context, which is relevant to the user? Is it factual given the context? Is it not just hallucinating? What is the overall rating? We ask GPT-4, is it excellent, average, or bad? And then how does it compare to 3.5? Again, these are all subjective. You can argue and debate about how does GPT-4 know whether it's factual or not, because it's itself an LLM. It will also hallucinate and all of that, right? But generally we have seen larger models do much better job at factuality and stuff like that. And it correlates with what we see in human ratings as well. And there are many, many papers coming out which are basically saying that instead of using human labelers, use GPT-4 as an evaluator, because for many use cases they are correlating well with what humans are saying. So now let's go forward. So here are some numbers. What you see over here is what is the output of, so let's say we basically given a question and given the specifications and the reviews or whatever, we ask, for example, is it waterproof or not, right? We rate each model, whether the answer was helpful and whether the answer was relevant. And what is the overall rating, GPT-4 rating out of 10. What we see is we compared with ChatGPT 3.5 Turbo, and we see that, okay, helpfulness is 94, relevancy is around 94.95. We take a Llama 13 billion model out of the box. We don't do any fine tuning, and we see what the numbers are, right? It's significantly worse compared to 3.5, right? And then we fine tune it with just PEFT. We fine tune it. We take a 7 billion model, right? We fine tune it, and then we take a 13 billion model and we fine tune it, and we see that fine tuning 13 billion models is actually performing quite comparable to what you see in 3.5 Turbo. Not to mention the latencies. The latencies I have not put for this one, but I will talk about other latencies. Latencies for this is much smaller, the 7 billion and 13 billion models, right? Let's look at another use case, query aspect extraction. We saw that given a query, 5G gaming phones, we have to extract aspects about that query. It's about gaming and so on. Many times, like in this case, best Samsung camera phone with 512 GB. You want to know that brand is Samsung, this internal storage is 512. These are objective attributes. Some are subjective attributes like best camera, and it's a subjective attribute, and that probably can be answered through reviews. And what are the budget end, right? I think the challenge has been that this is if you are been working in NLP for some time, this is a classical NLP problem. Given a set of text, what are the entities mentioned in it? What are the aspects mentioned in it, right? So why do we need LLM for this? What's happening is that the classical NLP problem is about aspects mentioned in the sentence, explicitly mentioned, right? It's not about talking about implicit aspects, and that's what we need to understand. For example, phones for elderly. I don't have an index called elderly in my search, right? All I know is that the display is large and keypad is true, because those are the attributes indexed in my index, right? What is LLM helping over here is that it's actually correlating that phones for elderly means these two aspects using its world knowledge, right? So what we are doing is we are giving the LLM a bunch of aspects that we know, and we take the query and we say, hey, whatever, ChatGPT, what are the relevant aspects, right, for this query? Phones with large memory, in fact, it will come up with standard values. What does large memory look like? Premium gaming phones, what does it mean, like quick charging, AMOLED display true, and so on. This has really helped us improve our search results, right, for Discovery Assistant. And as you can imagine, this is something that is, hit for every query. So it's a very expensive operation. So what we did over here was, we again took GPT 3.5 and we looked at the precision. This is a very simple evaluation, right? You are given a query, you have a bunch of aspects extracted, and you want to know what is the precision in recall. Basically, the aspects, if there are actually 10 aspects, and I extract 7 correct out of them, then my recall is 70%, and out of those 7, if I get 4 out of them, my precision is 4 out of 7, right? So I look, and then the F1 score is a combination of precision and recall. So what I'm doing now is over here, I report the accuracies of GPT 3.5. What's interesting is the numbers are quite bad, right? I think there is so basically, like if you look at recall, right, and F1 score, it's at F1 is 65 and recall is 50%. That means half of the aspects even ChatGPT is not able to extract. Okay, and if I fine tune a Llama model over here, I see that my precision has increased significantly and my recall has also increased significantly, and that has directly improved my accuracy of search results, right? So sometimes just using small amount of labeled data and fine-tuning these models works much better than trying to use a large model to solve your problem. Let's look at one more problem, right? You saw in the pipeline, there was a component which basically walks through, once you have the search results, FSN is the product 1, product 2, product 3, and you had the context for the product, which were the specifications and the review summaries. I want to ultimately come up with why this phone is relevant for this query, right? I have to give a reason to the user why this phone was relevant. And this is a task, and again, we can use commercial LLMs for this. And we tried in-house models, right? So the task is clear. Hope that is clear now, right? Yeah. So I'll talk about, this is a flow which was kind of generally applicable in most um, fine-tuning of in-house models. So what you start is you have a prompt, right, which we have anyway used with commercial models to get those summaries or whatever. We take the same prompt and we basically take like a large GPT teacher model, and given the system prompt and given the query, we take the summary, right? And we do some basic pre-processing, and we finally get, for this prompt, this was the input and this was the final output given by the GPT teacher. Now this becomes training data, large amounts of training data, to fine-tune a smaller Llama 2 model, okay? There are some ways to improve the quality of the training data. You can basically have some more steps in between where you remove some noisy examples by automatically figuring out what is noise and all of that, but this is the overall pipeline, right? So this is one way to scale up all your fine-tuning of in-house models, right? Take a large model, generate label data to train smaller fine-tuned models. And here is what you see on various dimensions, right? So if you compare query satisfaction, factuality, informativeness, and so on, how does GPT 3.5 perform? 3.5 Turbo, which was an updated version of GPT 3.5, then Llama 2 7 billion and Llama 2 13 billion, right? We are seeing that we are basically already beating the 3.5 models, right, with the fine-tuned models. And you can look also, other way to evaluate is compare whether 3.5 is better or Llama is better, the fine-tuned Llama is better, and basically even in the win versus lose ratio, you see that basically you get a lot more win for the Llama 2 models. And the latencies are much lower, right? If you look at a 7 billion model, that's approximately 4.67 to 2.37 seconds, right? That's, I mean, a user waiting for 4 seconds, 4 seconds is painful, to get the answer, right? And that's the biggest problem right now we have with these large models, right? So the more you can do to reduce this latency, that is helping, that helps, right? So let me. There are similarly, we are doing this for a lot of the use cases and flows, right, that we are seeing. So what are the key learnings over here, right? We basically started with commercial models. It enabled us to do quick experimentation. We have plethora of use cases where we are applying this, and like whether it's catalog, whether it is chatbots, whether it is health, travel, all of these use cases are lighting up very fast, right? And then what we are seeing is, okay, where are the challenges? Where is the cost problem? Where is latency problem? Where is accuracy problem? And all of that. And we basically started with fine-tuning these models, right? Fine-tuning open source models. And you can really minimize the human in the loop over here with respect to training. Evaluation, of course, you still need that. But with respect to training, you can minimize by using the teacher-student technique, which I talked about. And so it's a viable option for improving accuracy and latency. It is training and evaluation. I already talked about how we can create synthetic data to train these models as well as evaluate. But there are still many problems, and I think this is something which requires a little bit of thought, right? There are still very much domain gaps, right, between commercial and open source models. Both of these models, a large amount of data which is being used to train these models is open domain, right? There is Wikipedia, there is books and everything and so on, right? So it doesn't have all the knowledge that I care about for e-commerce. It has not all the knowledge that I care about my concepts like, Langa and those kind of things, right? It doesn't have knowledge about languages. It doesn't have knowledge Indian languages, dialects. Yes, it will work in multiple languages, but truly whether it is used to train the model, not clear, right? It doesn't have knowledge about my user preferences. It doesn't have knowledge about my user funnel. It doesn't have a knowledge about what products sell, under which categories and all of that. All of those it cannot recommend because it has no knowledge about that, right? What business metrics are important? Should I optimize for CTR or conversion? Should I optimize for engagement? difficult to do that, right? When training these models, because they were the way they were trained. So in order to kind of address that, right? And you saw, I mean, just to give an example over here, right? What is, even with the open source models, right, over here, we were able to improve, right, the recall of aspects from GPT 3.5 from 52 to 66 by fine-tuning Llama model, but 66 is still quite bad, right? We still have a lot of room to go, right? And the reason is because that the Llama model it's just completely trained on open domain data, right? It has no idea of what the e-commerce aspects are, right? So, and if you further go to English, you go to other languages and all that, it becomes even worse, right? So there is still a lot of room to improve over here, right? This is still not acceptable. And the way we are going to do that is, or I want people's help. I mean, these are founders over here, so we are throwing out problems to you guys, right? We don't know how we're going to solve this, right? But here is a proposal, right? So what we basically need is an e-commerce LLM model, right? There is a lot of data about e-commerce available. I think even if I could take the current open domain data and just change the data mix, right? Today, in the Llama models or whatever, or Chapter 3.4, 95% of data is non-e-commerce, maybe 5% is e-commerce. Can I change that data mix, right? Make it 50-50 at least, right? Or add more data sources which it may not be aware of. And then further add my proprietary data sources, right? Which it is not aware of, right? And train that model, which will basically give me an e-commerce based model, right? And then I can use it for various tasks, whether it is discovery assistant, whether it is summarization, whether it is aspect extraction and so on. Then basically build an instruction tuned LLM where all my instructions will be about only e-commerce. Today, all the instructions are about public tasks, right? Which a lot of the tasks, like writing a poem, for example, is not relevant, right, for e-commerce, right? So I only instruction tune on the tasks I care about, and build a smaller model, focused model, and that gives me a better instruction tune LLM. And then I basically further fine tune it like how we fine tune Llama models on the specific tasks. And this is the pipeline that can basically really improve the accuracies and latencies significantly, right? So that's where we are. There's still a long way to go. And I think I'm a little bit of, I have 3 minutes left. So we can still, if it's okay, we can still take a couple of questions. 1 or 2 questions? Okay, all right. Thank you, folks. Thank you. Yeah.
In the interest of time, we'll take your questions, sir, but I urge everybody else out here to utilize your lunch breaks and your tea breaks for networking and talk with our business heads and leaders to get your questions, queries answered. Yes, sir.
Yeah, my name is Gautam. I'm from Probe. How big is the team, sir?
I cannot talk about that right now. It's a small team, but not a very big team. Yeah. But see, I think our problem is also it's not a world problem, right? It's not like we're not trying to build LLM for the world. We're just trying to build a problem for e-commerce, right? So it's a much smaller problem, and with a smaller team you can do that. And by the way, we have our team, right, which is in Flipkart, but we are relying on all the development being done by open source. So ultimately, the extended team is all the open source community, right? Which is there, which is rolling out developments, like weeks after weeks. So we are riding that wave simply, right? So it's, I think I'll just give credit to those guys. Yeah.
I will take one final question from you, sir, since that was a very crisp question.
Hi, this is Sangram from Prodigal. Very specific question. In your comparisons, you didn't mention ChatGPT 3.5 fine-tuned anywhere. Is that on the chart?
It's more expensive. It's more expensive. Right?
Did you compare that in accuracy to the Llama 13?
No, I think one problem was that fine-tuning capabilities came out later, and then fine-tuning capabilities in Azure also came out even later, right? So I think we have yet to try that. But we know that cost-wise it will again be a challenge because those are more expensive than the non-fine-tuned models, right? But yeah, that's a fair point to know. That's something that we haven't done yet, and we would like to see that. Yeah.